We're going to continue with part D. In this case, remember, the functions h and j are inverses of each other. So they are telling me that they are inverses. Use the graph of h to find the given value. Explain how you found your answer. So in this case, what I'm going to do is for the first one, right? So I have j of -6 and is equals to -2. Why -2? Now observe this one. This grid, it goes by 2. So this is 2, 4, 6, 8. So here negative side is -2, -4, -6 is right here. And then I'm going to reflect it, okay, on my graph. So I'm going to have, in this case, going to hit the graph and then goes to the x-axis. So in this case is -2. That's why I determine what is the j of -6 equals to -2. Now, for the second part, in this case, they want me to do h of -2. h of -2. What is that one equals to? So I just reflect back. So I start with x equals, remember this one is x equals to -2, and I just go down to the line and reflect it, and it's equals to 6. So it's just a reflection on that graph. And the second part, I'm just going to do it to save a little bit of time. Have j of 4, okay? So we're still in j of 4. So remember, we're going to reflect it. This is 4, right? So what we get is equals to 2. In this case, it's going to give us 2 because it reflects it here. And remember that each line is 2, 4, 6, 8. Now the next one will be, in this case, h of 2. So it's going to give me 4. Let's go to part 3. I have j of -6. What is that one equals to? That one is equals to -4. And then if I do h of -4 is equals to -6. And the last one is j of 2. So I have the fourth part is j of 2 is equals to, in this case, if we look at the graph, is going to be 0. So h of 0 is equals to 2. Okay, so we're going to start actually solving, exploring in inverse functions. So I'm going to write a formula for the input of a function. So let fx equals to 2x plus 3. Solve for y equals to fx. For x, we're going to solve for x. Then find the input when the output is -7. So what it means, in this case, I'm going to write the function. So I have fx equals to 2x plus 3. I'm going to make y equals to fx. So I have y equals 2x plus 3. And now I'm going to solve for x. So I'm going to subtract 3. Let's get rid of 3. Minus 3. So what I have, these two goes away. Y minus 3. I just switch those two. Equals to 2x. Now I'm going to divide by 2. Right? Let's divide by 2. These two goes away. So I have that x is equals to y minus 3 over 2. Also, I just flip it. And what they want, find the input when the output is -7. So what they are asking me, what is x when y is equals to -7? So what I'm going to do is x equals to -7 minus 3 over 2. And this one is going to be x equals to -5. Okay? So in this case, I'm going to solve the input. So the input is -5 when the output is -7. I'm going to do b. I have y equals 3x minus 5. So same, let's solve for x first. So I'm going to have, in this case, y plus 5 equals to 3x. Then we divide by 3. So x is equals to y plus 5 over 3. That's what I have. Now they're telling me what is the value of x when y is equals to negative 11. So I'm going to have x equals to negative 11 plus 5 over 3. So x is equals to negative 2. Okay, so in this case, the input is negative 2 when the output is negative 11. Okay, so let's go over the inverses of linear functions. Okay, so I'm going to put this one. This is what you have on your textbook, this part. So in the previous example, the inverses of the linear function were also functions. However, inverses of functions are not always functions. However, for example, the graph of fx equals to x squared and x cubed are shown in this case. So look at the graph of fx x squared. So I have this parabola, and if we do the inverse, we will have x equals to y squared. Okay? So notice that the inverse of fx of x cubed is a function like this one. But the inverse of x squared is not a function. It gets restricted in this case. Okay? It gets restricted. When the domain of fx equals to x squared is restricted to only non-negative, not real numbers, so only positive numbers, the inverse of f is a function as shown in the next example. So in this case, it's not going to be a function. Okay, remember the vertical line test. If I do a vertical line, if it touches both 2 times the graph, is not a function. So in this case, I'm going to need to restrict to only positive numbers in order to become a function. So that's going to happen with the fx equals to x squared. Okay, and in this case, to determine the inverse of a function f is also a function if and only if no horizontal line intersect the graph of f more than once. So we're doing the horizontal line test. So if we draw one line horizontally and we touch only once, yes, the inverse is a function, but if we touch it twice, the inverse is not a function. So we're going to have that one in mind. So we have this one that we went over on the lesson. So we are going to solve some examples. But before we formalize, we solve some example, let's formalize the steps to finding the inverse of a function. So to find the equation of the inverse f to the negative 1 of 1-to-1 function, follow these steps. Step number 1, we're going to substitute y for fx. Step number 2, we're going to solve for x. Step number 3, we're going to interchange x and y. And then the final step, we're going to substitute f inverse of x for the y variable. So find the inverses. We're going to start with problem A. So I'm going to substitute the fx for y. So I have y equals 3x minus 1. Then I'm going to solve for x. So I have y plus 1 equals to 3x. Then we're going to, I can just like switch these to having like 3x equals to y plus 1 just to make formal steps. Then I'm going to divide by 3. So x is equals to y plus 1 over 3. 3 is multiplying, going to divide. So now what it says, the next step 3, interchange x and y. So I have that y is equals to x plus 1 over 3. And final step, substitute f inverse of x. So f inverse of x equals to x plus 1 over 3. And that's the solution to the problem. Okay. So now B, what I have, y equals x minus 8 over 2. Then we're going to multiply both sides because we're going to solve for x. So 2y equals to x minus 8. So So I'm going to have 2y plus 8 equals to x. Let's interchange. So I have x equals to 2y plus 8. Now I'm going to interchange x and y. So y equals 2x plus 8. And final step, f inverse of x equals to 2x plus 8. That's the solution that we are looking. Now, let's find the inverse of quadratic functions. And in this case, find the inverse of fx equals to x squared. X is greater than equals to 0. Graph the function and its inverse. We're not going to graph formally those functions. I'm just going to do a rough draft there. So what I have, y equals x squared. Then I'm going to, in this case, I'm going to interchange x and y. So I'm going to have that x is equals to y squared. How do I get rid of that square? Square root. So plus minus square root, these two goes away. So I have that y is equals to plus minus square root of x. Final, f inverse of x is equals to plus minus the square root of x. Now, if we graph this function, okay, I'm going to do a rough draft here. If we graph this function, remember this is a parabola. So I'm going to start from 0 and it goes up to positive infinity range. Now I have f inverse. I'm going to use the positive, so start from 0 and it goes this way. Remember, I am not going to draw the negative part of the parabola because the domain is restricted only to be 0, not the negative x values. So in this case, I'm not going to graph the other side of the parabola, okay, because of this domain is being restricted. Now we are going to solve problem B. Is x squared minus 2. So I have y equals x squared minus 2. Y plus 2 equals to x squared. So look at this one. I'm going to x squared equals to y plus 2. I just did the interchange of positions, not the variables. So now I'm going to do square root plus minus square root. These two goes away. X equals to plus minus square root of y plus 2. And now I interchange the variables. Y equals plus minus the square root of y plus 2. And f inverse of x is going to be equals to the square root of x plus 2. And now, so in this case, I'm going to use just the positive. I'm not going to have the negative, so my inverse is going to be positive square root of x plus 2. Same for this inverse here. F inverse of x is equals to the square root of x. Now, if we graph these ones, we're going to have something like this is 1, this is 2, right? This is going to be the inverse. I'm graphing the inverse. So x plus 2, that means it goes 2 units to the left, to the negative 2. And we go this way. And if we graph x squared minus 2, it went 2 units down, negative 2, and it goes up this way. So this is fx, and this one is f inverse of x. Okay, those are my graph. Next example, example number 4. Example number 4 is the inverse of a cubic function. Okay, we're going to have the inverse of a cubic function. And in this case, remember that the cubic function, we are going to be able to do negative numbers in the radical. So the first example that I have here is y equals 2x cubed plus 1. Now I'm going to solve for x. Y minus 1 equals to 2x cubed. Okay. Then I'm going to have y minus 1 over 2 equals to x to the third power. We're going to apply the cube root. Cube root. We don't need the plus minus. So 3 goes away. So x is equals to cube root of y minus 1 over 2. Now we interchange the variables. So I have that y equals to cube root of y x minus 1 over 2. So f inverse of x is equals to the cube root of x minus 1 over 2. That's my solution. Now is it a function? If we graph the inverse of this function, it will be something like this one. It will come this way, will go up, and then it will goes here. And if we do the horizontal line test, we can see that it is definitely a function. Part B, I have, this one is y equals 3x cubed minus 2. So y plus 2 is equals to 3x cubed. We divide by 3. Y plus 2 over 3 equals to x cubed. Apply cube root. Okay. Cube. This is 3. This goes away. So x is equals to cube root of y plus 2 over 3. We interchange the variables. So y equals to the cube root of x plus 2 over 3. And then I have f inverse of x is equals to the cube root of x plus 2 over 3. If we graph, we're going to have something like this one, and x minus 2. So it will move to the negative side. And we go this way. So definitely a function also. For this example, we're going to be careful with the first one because it's a square root, right? It's a square root. So I'm going to write y equals to 2 square root of x minus 3. Now we're going to proceed to solve for x. So I have y over 2 is equals to the square root of x minus 3. Now we elevate to the second power both sides of the equation. So to the second power to get rid of that square root. So these two goes away. So I have y squared over 4, because 2 to the second power is 4. Y to the second power is y squared equals to x minus 3. Now we're going to add 3. So I have x squared, y squared over 4 plus 3 equals to x. I'm going to interchange the variables and switch those equations. So I'm going to have that y is equals to x squared over 4 plus 3, which is my inverse function. So f inverse of x equals to, I can write this one as 1/4 x squared plus 3. Now I'm going to stop here a little bit because remember that this is a radical. So if I graph that radical, I'm just going to do something like this one. So if I graph this radical, I'm going to have something starting in 3, because it's negative 3, so move 3 units, and it goes this way. See that my range is restricted from y greater than or equals to 0. So in this case, my domain, because it's the inverse, is going to be restricted from x greater than equals to 0. So in this case, if the question is find the inverse, this is my inverse with the domain from x greater than equals to 0. I'm not going to have negative numbers in my domain. Let's do second problem. Y equals 3 square root of x plus 4. Okay. Then I have y over 3 equals to the square root of x plus 4. Now I'm going to elevate to the second power, both sides. This goes away with the radical. So I have y over 9, y squared over 9 equals to x plus 4. Y squared over 9 equals, minus 4, because I'm moving this 4. Minus 4 equals to x. I'm going to switch the variables and interchange the position of the equations. So I have that y is equals to x squared over 9 minus 4, or f inverse of x equals to 1 over 9 x squared minus 4. And remember, if we do this one, my domain is also restricted. X has to be greater than equals to 0. No negative numbers. Now we're going to do composite functions, composite of inverse functions properties. We solved one example at the beginning where the f composite of g of x is f of g of x equals to x for all x in the domain of g. And if we reverse that operation, we're going to get also x. So we're going to practice that one in a moment. So example 6 says, determine whether the functions are inverses. So determine whether the functions are inverses. So I have fx equals to 3x minus 1 and gx equals to x plus 1 over 3. So in this case, I'm going to do f of gx, okay? So following the previous lesson, I will have f of x plus 1 over 3. And I'm going to have 3 x plus 1 over 3 minus 1. See, I just replace this x for x plus 1 over 3. This 3 goes away. So what I'm going to have is x plus 1 minus 1. This is 0. So f composite of gx is equals to x. Now I'm going to do g of fx. Okay, so I have g of 3x minus 1. So I have 3x minus 1 plus 1 over 3. These two are 0. So I have 3x over 3. These two cancels out. So g of fx is equals to x. So in this case, these are inverses. See, we got x, so yes. Now let's do this one. So I have f of gx, and what I have, so I have f of the cube root of 2x, so I have 8 and parentheses cube root of 2x to the third power. These 3 cancels the radical, and what I have is 8 times 2x. 8 times 2 is 16x. See that is not x, so this is a no, not an inverse. These are not inverses. Okay. Final example is an application modeling real life problems. So the speed of sound in meters per second through air is approximated by fx equals to 20 square root of x plus 273, where x is the temperature in degrees Celsius. Find and interpret f inverse of 340. So what I have here is I'm going to find the inverse. So I have y equals to 20 square root of x plus 273. Okay, so I'm going to have y over 20 equals to the square root of x plus 273. I'm going to elevate to the second power. So I have y squared over, in this case is 400, 20 to the second power is 400. So equals to x plus 273. So I have 1 over 400 y squared minus 273 equals to x. Going to switch the variables and change the position of the equations. And I'm going to have that y is equals to 1 over 400 x squared minus 273. Remember that domain. Okay, so f inverse in this case of x is equals to 1 over 400 x squared minus 273. Now what it says here that where x is the temperature in degrees Celsius, find and interpret f inverse of 340. So I'm going to replace f inverse of 340 is equals to 1 over 400, 340 squared minus 273. What do we get? If we plug in this one in the calculator, I'm going to plug in that one in the calculator. This one is equals to 16. That's going to give us 16. How do we interpret that one, the solution? Okay, so in this case, this represent that the function or the temperature is 16 degrees Celsius when the speed of sound through air is 340 meters per second. Okay, that's going to be a solution to the application. Remember that this domain is going to be restricted to positive numbers, x greater than equals to 0, and that's the end of the nodes. So thank you very much.